Hello, this is Jasmine Kim and I'll go over my queries. This is the best simple one. Proposition is find out the list of products that have never been sold using AdventureWorks 2017. The product table is joined with the purchase order detail table using the left outer join. Proposition, get the running total of the orders by year using Northwind's 2020 T-SQL v7. To get the running total, first create the view that summarizes the sales total by year. In this view, use the group by year, by order date, and use the sum function to get the total of the sales. In the outer query, use a subquery in the select clause. The main query will then join the view to itself in the select clause. The operator in the where clause of the running total queries will be less than equal to add the current and all the previous year's sales with the sum function. Next one, best complex. Proposition, find the top 3 most expensive items each customer has ever purchased. So what I would do here is create an inline table valued function that takes in as parameters the number of items to display and the customer ID. This function performs a join with the sales order detail and sales are order tables to output the product data with the customers who ordered. It does a filter here whereby individual customer. Order by is essential here in order to output the three most expensive products instead of every product the customer has ever purchased. The main or slash outer query, which uses the inline table valued function, will perform a cross apply with the customer table to output all customers who placed an order and their products. The row number function is used to specify that there are 3 products per each customer. Proposition, find the customer contact title, customer ID, customer region, and customer postal code. Give the owners and sales agents their own number. Replace the empty/null customer region with more information. So first, create a view that filters for the owners and sales agents. In the main/outer query, use the row number function to generate a unique number for each owners and sales agents. Use the coalesce function to display no region whenever there are nulls, and use the concatenation function to generate new label for owners and sales agents. And the bad thing about this was that, you know, so many instances of the single table was used. So then there's a lot of unnecessary clutter. So this is just cleaned up version of this, and instead of invoking the same table inside the table expression, then joining the original table to the table expression, the original table, the sales at customer, is invoked just once in this query. Proposition, show percentage of each employee's order total as a ratio of the employee's total orders serviced. Also, show percentage of the employee's order against all orders. So in this query, there are 4 subqueries in the select clause, but there are actually 2 of them and they're repeated twice. The first subquery contains the total sales amount serviced by each employee. The second query right here is obtains the total sales amount of the entire company. This query shows the impact each order and each employee has made toward the company's overall profit. The number of times the subqueries invoked clouds the overall query. So I decided to make a scalar function here that returns the total sales amount for each employee. So I just sort of got rid of the first subquery but I just kept the second one because I think it was a little bit more simpler than the first one. So the use of the scalar function kind of reduced the several lines, many lines from the original query and is more readable. Worst complex one. Proposition. Our company is having a special discount for families with children. The discount varies by the number of children. Show how much discount each family will receive. So I would say, even before we get into the query, the proposition I think was really at fault here because the discount period has not been specified, implying that we give discount for all orders ever placed, and this would surely lead a company to bankruptcy. The most grave mistake I've made here is the where clause inside here, and we have to get the totals per customer, and I just do this for per each order, so it looks very cluttered in general. And the query simply outputs the discount percentage and does not actually calculate the actual amount of money the customers will receive discount on. So here's the correction. So what I did in this revised proposition is that I specified the date that the discount was going to happen. And the two inner joins inside the common table expression, I just got rid of it because I was like, I don't really need the employee key in the yeah, first I just had this, and then the problem was that even though the date was specified on the outer query, the inner query was calculating the total sum of all orders the customers purchased, so not just the ones on May 3rd, 2013. So I had to add another date filter within the subquery of the CT as well. So I added that column. And finally, I added a column that calculates the actual discounted amount to satisfy the proposition.